Welcome everyone, this is your math tutor Naresh. This tutorial is about introduction to exponents. We're going to learn about exponents. We're also going to learn how to read them once an expression is given to us. And also we're going to look at two special cases when we have an exponent of 0 or an exponent of 1. Alright, so let's get started. So we're given something like this. So we see a number which is a 3, and then we see another number written on sort of top to the right of 3, and that number is 2. So we call this number the base, and the number on the top right is called the exponent. So this is read as 3 raised to the power of 2. The power is 2, second power. Now what an exponent means is, so this exponent is giving instructions to the base. Giving instructions to the base to multiply by itself this many number of times. So the exponent, it's giving instructions to the base. So it's giving instructions to the base to multiply by itself. So multiply by itself that many number of times. So that many number of times. So what this means is, so 3 to the 2, the exponent is 2, so it's telling the base, which is 3, to multiply itself twice. So 3 to the 2, what this means is the base gets multiplied 2 times. So the exponent is 2, the instruction for the base is to multiply by itself 2 times. 3 times 3 is 9, so we can simplify and the answer is 9. Okay, so we have a base, we have an exponent. Exponent simply tells the base to multiply itself that many number of times. And the one other thing you should know is the exponent always applies to the base that immediately precedes it. So that means sometimes we can have more than one base. So an example would be, let's say if I have x to the 2, so that would mean multiply x twice, right? So the exponent is still 2, so we would say this is x times x. Okay, so that's how that is interpreted. That is now if I say something like 3x to the 2, so when I look at something like this, the exponent of 2, it applies to the base x. It does not apply to the base 3. Remember, 3 is also a base and x is also a base. So the exponent applies to the base that immediately precedes it. So that is, the 2 applies to the base that is just before it, right? So 3 is also a base, but it's not before the exponent of 2, right? So 3 also has an exponent. It has an exponent of 1. So we don't bother writing that 1. So by default, it is understood that when there is no exponent on the base, the exponent is 1. All right. So two things we learned here. The exponent means it's giving instructions to the base to multiply by itself that many number of times. And the second thing we learned is that the exponent applies to the base that immediately precedes it. So two things we learned. All right. Now let's look at some examples so we can grasp this concept. So now if we have x to the 4, so what does that mean? What it means is we multiply the base x 4 number of times, right? So 4 times. So the exponent is 4, we multiply the base 4 times. 1, 2, 3, 4. So x is multiplied 4 times, and this dot in the middle, it's a multiplication symbol. Okay. So now what if I have 2, let me use a different letter, 2z to the 3. So what that means is we have an exponent of 3, the base is in brackets, so the 2z, that's the entire base. So this exponent applies to the 2 and the z, right? So what's inside the bracket is our base. So we multiply our base, which is 2z, that's 1 times, second time 2z, and then the third times 2z. So that's how we write that. Maybe z wasn't a good variable, it looks similar to 2, but we can distinguish it. We have a bar, right? And then on the 2 there is no bar going through the 2. Now, just a slightly different way or different example, what if I had 2z to the 3? So in this case, the exponent of 3 only applies to the base z. The exponent of 3 does not apply to the base 2. Remember, the base 2 has its own exponent, 1, and we don't bother writing that. So if I were to rewrite this without exponents, this is how I would expand it. So this 2 gets copied. So it's now the z to the 3 that we can expand, right? So z will get multiplied once, twice, and 3 times. So that's how you would expand this. So you should make a distinction between these two. What do you learn from here? What you learn is here the base is in brackets. So even though we have 2 bases, right, the 2 and the z, but the whole thing is treated as one single base because it's inside the brackets. And the exponent of 3 applies to everything that's inside the bracket. So our base is 2z. So 2z gets multiplied 3 times, once, twice, and third time. In here, there are no brackets, so the base 2 and the base z are independent of each other. The exponent of 3 applies to z, so when we expand it, it's z that will get multiplied 3 times, once, twice, and 3 times. The 2 in front, it has its own exponent, 1, right? So here, 2 to the 1. And we don't bother writing 1 because it's understood. So that's the lesson here. You should make that distinction that the base, that the exponent applies to the base that immediately precedes it. All right. So now what I'm going to do is, so let's look at how we would read some of these things. So if I have x to the 5, and I'm not going to write it, so okay, maybe I'll write it for this one. So this means multiply x 5 times. So once, twice, third times, fourth times, and fifth time. So that's how it goes, right? So, but I'm going to erase it because my purpose here is not to expand. My purpose is to show you how we read these. So this is simply, we can, this is how we read it. We call it, so x raised to the 5th power. So x raised to the 5th power. So power is actually another word for exponent. Okay, so this is how we read it. X raised to the 5th power. Or we can simply call it x to the 5th. So for short, and this is what I use, and this is what is most commonly used. So I'm introducing this so that you have the proper language, but in short, we go with this, x to the 5th. So x raised to the 5th power, right? So then we have x to the 4. So this would be, instead of the 5th, it would say 4th, right? So x raised to the 4th power, or simply x to the 4th. So I'm going to say x to the 4th. That's how we read that. And then x to the 3, and you heard me say it, x to the 3. X to the 3. And we work with 3 a lot, so it has a special name. The 3, when you have an exponent of 3, it's called cubed. So we can say x is being cubed, so we can call it x cubed. X raised to the exponent 2, or x raised to the power 2. So x to the 2. So that's the most common name for this, x to the 2. And again, 2, just like the 3, has a special name. It's squared. So x squared. And then x to the 1. So it would be x to the 1. Or simply x. Right? X to the 1, it's x. Right? So, and actually we can go x to the 0. So this is called x to the 0. So that's how we read. So we're given a base with an exponent. This is how you would pronounce x to the power, x to the 5th, x to the 4, x cubed, x squared, x to the 1, x to the 0. All right? Okay, so let's move on. So now let's look at the exponent of 1. So when we have an exponent of 1, so let's say 3 to the 1. So 3 to the 1, it simply means you multiply 3 by itself only once. So it's just 3, right? When I write, so there is no more times 3 times 3 times 3 times 3, because you only write it once. The exponent is once. So 3 to the 1 is 3. And if I go 2 to the 1, it's going to be 2. If I go 4 to the 1, it's itself, right? 5 to the 1 is 5. 6 to the 1 is 6. 7 to the 1 is 7. So basically, when you have any base raised to the exponent 1, it's just that base, right? So you're multiplying that base only once, right? Which means you're not really multiplying, you're just copying it. So anything raised to the exponent 1 is just whatever that base is. Now, we'll look at an exponent of 0. So now if I have one exponent, base 1 raised to the exponent 0, now how do I multiply 1 0 times? Right? It's just not possible. So I can write 1 once or twice, through a third time, four times, 5 times, and so on. I can write any number once or more than once. But how do I write it 0 times? Right? It's not possible. So by mathematical definition, when we have an exponent of 0, the answer is always 1. So this is by definition. So by default, by definition, anything raised to the exponent 0 will always equal to 1. So, okay, so now if I have, let's say, 3, actually before I do that, let's just do a variable. X to the 0, that's going to be 1. So what if I have 3x raised to the exponent 0? That is also going to be 1. What if I make up like something really like complex or weird looking? So let's say x raised to the exponent 1 over 5, square root of y, and then let's put 31 in front, and then we raise the whole thing to the exponent 0. Now this is really complex thing. Does it even make sense? I don't know. But that is not a matter of this tutorial. What we're learning here is how the exponent of 0 comes into play. So regardless of what we have inside the bracket, all of this is being raised to the exponent 0. The answer is going to be 1. So that's what we want to learn in this section, right? So anything raised to the exponent 0 always equals to 1. Okay, so now, so now what if we have 0 as the base? So it's no longer the exponent, so now we have a base of 0. So instead of exponent, so what if we have a base of 0? So 0 raised to the exponent 1, well, that's going to be 0, right? 0 multiplied only once. What about 0 to the 2? So that would mean 0 times 0. What's 0 times 0 is 0. Okay, 0 to the 3. Multiply 0 3 times. So 0 times 0 times 0 is 0. And so you get the pattern. So 0 to the 7 will still be 0. So when you have 0 raised to any exponent, the answer will always be 0, right? Because anything that you multiply with 0 gives you 0. So if you multiply 0 by itself, no matter how many number of times, it's going to give you a 0. Alright, so now what about a base of 1? So instead of 0, what about base of 1? So, okay, 1 raised to the exponent 1. So we multiply 1 by only once, so that means you just copy it, right? So it's 1. Okay, so what about 1 to the 2? Here it means you multiply 1 twice. The exponent is 2. So 1 times 1 is 1, right? Okay, what about 1 to the 3? 1 to the 3, so it's going to be 1 times 1 times 1. It's going to be 1. And again, you get the pattern, 1 to the 4, 1 times 1 times 1 times 1, so it's going to be 1. So 1 multiplied by itself, no matter how many number of times, you're always going to get 1. Alright? Okay, so now we're going to take a second look at this. Just so that you build your understanding. Now, what if I have 1 raised to the exponent 1? I just put 1 inside the brackets, and then you'll see why. So it's no different from what we just finished. This is 1 to the 1. The answer is 1. Now, what if I have 1 squared, right? So 1 squared, 1 times 1 is 1. What if I have 1 to the 3? So that's also 1. What if I have 1 to the 4? That's also 1. So where it's going to be different, so what I want to show you now is, what if I had a base of negative 1? So negative 1 raised to the exponent 1. So here I'm multiplying the base negative 1 once. So the answer is negative 1. Let's do the next question. Negative 1 raised to the exponent 2, right? So you can see I'm comparing these. So here what this means is I am multiplying negative 1 twice, right? Because that's what the exponent tells me. Multiply this base of negative 1 twice. So now I remember my multiplication rules from previous tutorials. Negative times negative is positive, and 1 times 1 is 1. So what I get is positive 1. Let's try the next one. Negative 1 to the 3. And also what I want to point out is when you have a negative base, right, you want to put that inside the brackets. So here it doesn't matter in this on this side because the base is positive. But once you have a negative base raised to an exponent, you want to put the base in brackets. Now this means multiply negative 1 3 times. So again, I'm going to apply my multiplication rules. Negative times negative is positive, times negative is negative. Negative 1 times 1 times 1 multiplied however number of times by itself, I'm going to get 1. So I'm getting negative 1, right? You follow? Let's do the last one. So that's negative 1 raised to the exponent 4. So this means, so negative 1 is multiplied 4 times. So what's the sign on this going to be? Negative or positive? We have even number. So negative times negative is positive, times negative is negative, times another negative becomes positive. So it's positive 1. So the lesson here is here I had a base of negative 1. So when I have negative 1 raised to an odd exponent, the answer is always negative 1. And when I have negative 1 raised to an even exponent, the answer is always positive 1. So this is what you want to learn from this. So when you have a negative base, if you have even exponent, we saw that, even exponent here and even exponent here, right? The 4 and the 2, we're getting a positive 1. So even, it's positive, and when it's odd exponent right here, 1 and 3, the answer is negative 1. Okay, so that's what I want to point out, and I think now you're ready. You can so this is all that I wanted to introduce in this tutorial. This is introduction to exponents, and now it's just a matter of practicing. So I'm going to end this tutorial here, and I'm going to be doing 2 more tutorials on exponents where we're going to do some examples, practice questions, so that you grasp the concept. Thank you for watching, and if you found the video helpful, please like or subscribe, and we will see each other in the next 2 tutorials. Once again, thank you for watching.